All right. So in the last video, we talked about the basics of domains and basics of the functions in their domains. Now we're going to look at operations with functions, which here in this example, we would call this combining functions because I've got two functions and I'm going to either add, subtract, multiply, or divide them. We would call those combining in some way. Now these first ones go by pretty quickly. Just catch the way it's being written and then see how easy the work is afterwards. The way we would start number one is, well, any quote unquote good mathematician initially does substitutions with parentheses. So now here's the plus sign, and then G is this. All right, so that's all that's saying, f plus g. What they want you to do is write the entire function f, put a big plus sign in between. I kind of made it bolder just to visually see it, that was the one from the prompt. And then I want to add g entirely. Now notice again, I wrapped f and g in parentheses. However, that was just a visual cue for us to say, here is f and here is g. But here's what I know now as your professor and what you need to learn to know is that if all we're doing now is no number out front and no negative out front or no exponents, those parentheses weren't necessary and we're just combining like terms now. And I'm going to do that really, really quick. The combined like terms here would be 3x squared because there was only that x squared term. A negative 11x and a positive x is negative 10x. And 8 and negative 1 would be plus 7. So there we go. And what we also need to call out is the domain of this. And so the domain of this would be negative infinity to infinity because there are no fractions and there are no square roots in essence. So there we go. Up next, let's do f minus g. Now again, we should make that substitution with parentheses at first. That's 3x squared minus 11x plus 8. But now it's minus the x minus 1. Be careful when you go through this one because this negative distributes. Goodness. So it's now, before we combine, it's now 3x squared minus 11x plus 8 minus x, but it's also plus 1 from that double negating that we just did there. So that is why a good mathematician initially makes substitutions with parentheses, because this time that parentheses needed to be there to show you that that negative goes to both parts. From there, that was the hard part, so to speak, and all we have to do now is simply combine. So we still have 3x squared, we now have negative 12x, and we now have positive 9. That's my new answer. And guess what? That one's domain is still negative infinity to infinity because no fractions, no square roots. All right. Up next, this one is some good foiling practice, only this isn't quite foiling because there's more than two terms for this first one. And in fact, we're going to run out of space here, so we're going to do this up top so that we have the space to do it. Whoops. All right, here we go. So when I have this 3x squared times x, that's going to be 3x cubed. When I then have 3x squared times negative 1, well, that's negative 3x squared. But I'm not done yet because now there's this negative 11x. That multiplies to x, and that gives me negative 11x squared. Now watch this. I could write it all in a line, but because I've already seen an x squared, I'm going to start stacking my like terms underneath each other just to keep them in one place because I know they're going to combine later. Or rather, we should know they combine later. From there, I now have a negative 11x times a negative 1. That's positive 11x, and I haven't seen just a regular x term, so there we go. I'm still not done because there's now an 8. And 8 multiplies to an x, which would be 8x. Put the like terms underneath one another. And then 8 multiplies to negative 1, which would be negative 8. From there, I just have some like terms to combine. So this is 3x cubed minus 14x squared plus 19x minus 8 and we're done. Finally, what's the domain of this one? Well, this one does not have any square roots. It does not have any fractions. So you guessed it, this one's domain is negative infinity to infinity. All right, the last one we have 3x squared minus 11x plus 8 divided by x minus 1. And so for this question, um, we have divided them, but right now I can go ahead and tell you there's an issue with my domain because there is algebra on the bottom, and I don't want 0 to end up being what I get on the bottom. And so if you can look at this, we're going to say our domain here, we can say that now, is negative infinity up to 1, and then after 1 to infinity. I can't plug in 1 because plugging in 1 would make 0 in my denominator, and 0 in my denominator is big issue. Now, we've written it out here, and I'm not putting a box around this yet because what I need to spend a second thinking about, or what we need to spend a second thinking about, is does this actually factor? But I want you to notice that we already called out the domain right after that initial substitution. Okay, so what do I mean by does it factor? Well, remember, we did learn how to factor by grouping. Now I'm doing this really, really quick, but this is where you kind of want to land with time and practice is there's not a lot of ways of making 3x squared. All right. There's only 3x and x. Now there are some few ways of making 8. It could be 1 and 8, it could be 2 and 4. But what I'm looking at right here is I'm looking at this x minus 1 and wondering if that's going to show up. And so maybe I can plug in 1 here and 8 here and see if I could work that out. I would get a 3x squared. I would get a 3x and an 8x. Can I make 11 out of 3x and 8x if I add them together? Ooh, the answer is yes. And how do I get negative 11 out of 3x and 8x as I would FOIL it out? Well, they would both have to be negative. Because then, now watch this, I've now factored this by grouping without writing all the work because I guessed and checked my way, and I also assumed, hey, I bet one of those parentheses might be an x minus 1, because wouldn't that be interesting to have it on the top and bottom? And I guessed correctly, but it led me to my factoring again because I can now multiply this. That is 3x squared, that's a negative 3x, that's a negative 8x, which combine to negative 11x, and then finally those last two, the L of FOIL, multiply to positive 8. Now this is my algebra, which means on my last step, whoops, these cancel, and I'm left with 3x minus 8. And this is really interesting. For the first time, I'm going to have to pull up a graph for you. All right. And so let's type in that original question. There was a 3x squared, whoops, 3x, I know I need a fraction later, a 3x squared minus 11x plus 8 over x minus 1. Now here's the really interesting thing I want to point out is, and why we wanted to show you this factoring, is take a look at what this looks like. This does not look like a crazy ugly graph. This looks like a line. And you're right, it is a line, and you actually know the answer to what that line is. It's 3x minus 8. This graph has a y-intercept at negative 8. It has a slope of up 3, right 1. If you were to take a look at it, up 3, right 1. Yep, there it meets again. Up 3, right 1. Yep, there it meets again. Up 3, right 1. There it meets. So its x-intercept is an ugly fraction because of that up 3, right 1. Didn't meet perfectly on the grid, but that's okay because we can always just use a point and a slope. Now, what's interesting, though, is take a look at if I take my mouse and hover over positive 1, oh, right there, there's that open circle. And that right there is where your domain got split. Now, a graphing tool, again, won't show that unless you click and highlight over it, that it now shows that open circle. Or in other words, it shows us that even though my algebra simplified and eventually the thing that would cause issues went away, If it wasn't allowed in the initial substitution, it doesn't matter what your graph simplifies to. It matters, were you able to get 0 in the denominator at some point with your algebra? And I was if I plugged in 1, so 1 must be excluded. And so even though this now looks like a regular old line, at 1, it is excluded. Very, very interesting. All right, we now move to probably the trippiest section of this whole chapter, and it is composing functions. Now, this does not say fog. It actually says the same thing that you see right here. It's just written differently. This is pronounced, or the way you say it is f of g of x. Now, another way of saying that is we're about to plug um, g into f of x. And that's more clearly stated here on the bottom with the way that's written. But you need to know that f of g of x right here is the same as writing it like this. But I think this gives a clear visual picture of what we're about to do. We have f of something. It doesn't quite look like it, but again, it means this. So let's dive in and see what we mean. This is a really, really big concept. We're plugging functions into one another. And so that means if f is the main function, f of g of x, again, is how you say it in order, well, let's copy f, but let's be vague. That is what f is doing. We're just writing x as a placeholder, but x could be anything. And so we're writing the function f of x in its most abstract sense. It's really f of stuff equals whatever I just said minus 3, right? That's all f does, is it says I'll take whatever you plugged in, I'll subtract 3 from it. And now, watch this. Rather than fill that in directly, this is to help you as you work out your notes, I'm going to copy this again and say, this is like the skeleton of f, and I'm now about to plug g of x into it. And I'm going to borrow the notation from below, and I'm going to say, this is saying I would like you to plug in g of x. We'll take a look up above. On the left of the equal sign, g of x is literally the symbols g of x. But on the right of the equal sign, g of x is 5x squared minus 2. That's what I substitute into the parentheses. So congratulations, you just composed your first functions. What I want you to notice, and what makes your life easy on these, is notice again the ordering of how this works itself out. We first said f of g of x in order, left to right. So we copied the skeleton of f, the thing we said first. After we copy the skeleton, we recopy it so we can fill it in with, in this case, g of x. And again, g of x has literally g of x on the left of the equals, but it has this algebra on the right of the equals. So where I had my skeleton to be filled in, I filled in the 5x squared minus 2, the algebra of g of x, on the right-hand side. Now all we need to do there is then work that out, and thankfully the parentheses don't need to be there anymore. They were just there to help us. I now have 5x squared essentially minus 5. Because the parentheses aren't necessary, there's nothing to distribute, there's nothing to square. We don't need them anymore. We just needed to see what we were doing as we were composing. There's my new answer, and by the way, that one's domain would be negative infinity to infinity. Okay, if that craziness made sense, then maybe try the next one. But here we go together. G of x is the now thing I'm saying first. G of f of x. And so again, it is the same as what's going on here on the bottom. Again, if you wanted to kind of write it like this to say those two are the same thing. They mean the same thing. This one looks a lot clearer what we're doing. But this, again, is equivalent. So let's copy the skeleton of G. G says I'll take 5, or I guess if we go in order according to PEMDAS, I'll take whatever you plug in, I'll square it, I'll multiply it by 5, and then subtract 2, if you talk about that in PEMDAS order. So there's the skeleton of G. The X just got replaced with a big old blank parentheses. Keep that there, again, so that you can see how this got filled in later. Maybe make the parentheses wider just in case you need it. And now g of x will be filled by f of x. F will be inserted to the function g. And so I've got, again, f of x is written on the left of the equal sign, and the algebra of f is written on the right of the equal sign. And that algebra is, x minus 3. All right. Now, this one is trickier to expand out, but technically this is the right answer. I'm going to very quickly write out what the other answer would be here. And the other way you could write this is you could end up foiling out the x minus 3. I'm going to skip showing you that and trust that you could do that with time and practice because it should have been learned in the other sections. That's what you get if you FOIL out x minus 3 squared. If you then distribute the 5, that would be 5x squared minus 30x plus 45, but I'm going to cut right to the answer. If that's plus 45 and then there's a minus 2, then that's really plus 43. And there's my answer. Interesting. All right. Now this does have some implications for later. I'm just going to point this out as foreshadowing, is I want you to notice that evidently there's a way to take a quadratic and go from or to something that looks like function transformation steps. Right 3, down 2, vertical stretch of 5. I don't really see that here anymore as clearly, but it is still there. And that's uh, as the memes say, foreshadowing is a literary device. And if you laughed at that, then great. If you didn't, great also, because it means you're not terminally online. Okay, f of g of 2. Goodness. The idea is this. F of g of 2 is really saying, well, wait a minute, didn't I already find out what f of g of x is? Couldn't I just plug 2 into here? The short answer is yes. So if I plug 2 into this result, I will have found f of g of 2 because I found the new form of f of g of x. If you work that out carefully, you're going to end up getting, let's see here, 4 times 5 is 20, minus 5 is 15. So the answer is 15. And we should do it though, but let's work this out and show how that works. This is kind of interesting. When you have numbers instead, you go in reverse order. What do I mean by that? Well, now that I have an actual number to evaluate, the first thing I should do is actually plug in 2 directly to g, if I didn't already do all this work. If I plug 2 into g, just 2 into g, then here's what happens. I would get 5 times 2 squared minus 2. If you work all that out this time, that's still 4 times 5 is 20, minus 2 is 18. So I now know g of 2 is 18, but I want f of g of 2, or in other words, I want f of 18. What's f of 18? F of 18 is 18 minus 3. Guess what that is? 15. So there's two ways of going through this. I hope you caught that. That when there's a number to be plugged in, we kind of read it from right to left. 2 needs to go into G. I took 2, I plugged it into G, I got 18. That result needs to go into F. 18, my result of G, gets substituted into F. It got me 15. Because we did the prep work of figuring out the new general function, I want you to notice how easy that was, though. We got 15 way quicker and with way less mental effort because we already took the mental effort to define this new function. All right, we're going to go faster through these next two, and we might not simplify and write them out, and I'll leave that to you. But let's write our skeleton here. So there's my skeleton, F is the first function. Now that we're back to all algebra, we go from left to right. F is my blank function, and we're about to fill that with g of x. Might need to make that parentheses bigger, or I can just write smaller. But g of x goes on the left, and because it was on the left of the equals, on the right of the equals, or in the other parentheses, goes all of this algebra. Goodness. I'm going to put the box around that, but what you should do for yourself is distribute the 2 and then combine wherever that plus 4 could be combined with. It looks like with a positive 10, but we're not going to do that for now for sake of time. Let's go the other way. G is my outer function. Now watch this. My outer function is something squared minus 3 times something plus 5. So notice that that outer function had more than one thing. Also, again, for sake of time, I'm going to skip copying this, but you should. And I'm going to start filling this in with f of x. And again, f of x was 2x plus 4, 2x plus 4. All right. Also, what you can see here, I did take the 2x plus 4 and I did FOIL that out. That's what I got from those 3 terms. I did take the negative 3 and distribute it. That's what I got. And then there's still the plus 5. And if you combine all those like terms, there's your final answer. I know I literally just sped through that and pointed it to you, but just wanted it to be there so you could check your work without going through writing it out. Finally, g of f of 7. Well, careful, g of f of 7, that's this one over here. So the easiest thing to do, since we did all the work, is plug 7 into here. And that is what I'm going to do, again, for sake of time. But there's another way you could do it. You could plug 7 into f and get your answer, which actually would be 18. You could then take 18 and plug it into g and get the same result, but oh well, we'll go with what we have here. All right. From there, well, let's see here. 7 squared is 49. 49 times 4 is, I believe, 196. Then we've got 70. Then we've got 9. And 79 and 196, goodness, is 275. Should be your answer for g of f of 7. And really, I would recommend try it the other way. Plug 7 into f, get 18. Plug 18 into this, see if you also get 275, and that'd be a good check. And for sake of time, we'll cut this video off here, and we'll finish those last 2 questions and all of 2.7 in the next one to kind of keep things consistent time-wise. I'll see you then.